Ajay, have they come? Hello. Has the team come?
Yeah. The first guy is here. So we'll start with it.
Yeah, please start.
Am I audible, sir?
Yes, screen is not visible. I'm just coming in.
Yeah. Okay.
Screen is not
Okay.
visible.
No, I haven't shared it. I'll start it now. So there was one guy only. So like he has to go for it. Sure, go for it. Yeah. So where's your slides? That robust one. Yeah. The robust one, right? Not this one, but this one, right? This one, right?
No,
Then
a model asset.
this one, right? This one, right?
Yeah.
Okay. So you have to do this. Sure. And is the screen visible, sir? Yeah. Uh-huh. This again, one. Is this? I think you should get the remote. It's already on. Sure. Speakers. Yes, speakers. The surrounding one. Let's switch on the button. Okay. Good question. Oh, sir, it's like honestly, he'll be coming here. Just 2 minutes. Okay. Just make the teams share their respective PPTs.
Yes.
Yes. Mostly it will be online. If it is on offline, then you have to.
Okay.
Yes, you got the connect, right? That's nothing more. This is the connector, no? Display or right here.
Yes.
And then the impression.
Okay.
Oh, yes. In future. Yeah. Somebody connected to this Teams. Right?
Mhm.
Hey, hi. Sir, am I audible?
Yes, you are.
Hello?
Please get started.
Okay. Hey, please start.
Can I start? So, hello everyone. Today I will be presenting learning to selected toward sample for meta reverting by the professor of Pennsylvania. So the contest is this paper taken a case on training neural networks dealing with imperfect data like a noisy level or a class imbalance where the some categories have a fewer examples. These problems are common in real world data set and can hurt how well the model is performed. So the problem is problem is to focus on the technique called meta reverting. which use a small imperfect data set, small perfect sets of small perfect sets of samples called meta samples to guide a training. But choosing these meta samples is critical, and many methods just assume they already available. So objective is their goal is to create a framework that pick a high quality meta sample from a big messy training set and make meta reweighting work better. So they turn this selection into a weighted k-mean clustering problem and offer two solutions: represent representation based clustering and gradient based clustering. So the problem statement is so large language models. These are huge models trained on the tons of data like text from the internet, but not all data is equally helpful. So the sample qualities matter. So some samples are hard, very informative, and challenging to learn, while the other are noisy, misleading, or wrong, and can mess up training. So normally all samples get some attention, uh, which waste effort and data lead to weaker the model and also use computational power. So the solution is uncertainty aware training, meaning the model is adjust how much it care about each sample based on how useful or noisy it is. So challenges like imperfect data, like noisy level or uneven class size, make model less accurate. Uh, so we use meta reweighting technique. This is a smart way to fix this. It uses a small set of perfect samples to, to week how much each training sample matter during learning. So the problem is uh, current method. Problem with the current method. Most assume you already have a good meta samples. Uh, Often picking them randomly, this can fail badly. For example, random picking might give a six. Yeah. So, for example, random picking might give a accuracy of 56.3, and the smart one, which is GVC, give a 92% accuracy. So, imagine a simple 2D data set with four groups of points: two leveled green at top position, and two red at the bottom, with a bit of a level noise. Uh, some point are mislabeled. So if you pick a meta sample randomly, the model accuracy is just 56.3%, and the decision boundary is messy. Using paper method, RVC gets 73.3% accuracy and GVC gets 92% accuracy. The boundary fit much better. Uh, so come to that technique which is meta reweighting. So meta reweighting is learn two things together: sample weight, how important each training sample is, and the model parameter. Then number of model uses to make prediction. So this is Y level optimization. It uh, it it has two parts problem. Outer goal, the minimize the error of the meta sample, and the inner goal is train the train the model on the training sample weighted by their importance. So
So
here,
in this,
yes sir.
so in this process,
What sir? Please ahead sir. Yes ahead sir coming. Yes, sir. Yes, sir. Theta is the parameter, model parameter, sir. So, uh, dtrain is the data, training data, and the dmeta is the data which is used, which is accurate data uh, extracted from the trained data. Yes. So, so here is the optimization problem. We have to minimize this function such that the model parameter is uh, equal to the function. So, yeah. So the process is repeat until the model gets good. So adjust the model parameter like theta using the current weight, and so first update the model parameter, and then update the weight, and using the updated weight we again update the model parameters. So um, XGYZ is the training sample, full data sets, and meta sample is the extracted meta sample from these training set, which is good and contain more information and good. No, no, this is the technique, rebate technique. I will explain. So the main goal is to extract this D metadata. I mean, yeah, yeah, we just introduced here. FJ, so F meta is uh, so F meta is a model uh, on meta sample, like D meta data set which we extracted from the training sample. Retrain, yeah. Yes, sir. Yes, sir. So model improve the bed adjust and repeat until it is stable or converge. So 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 we use MSSO, meta sample selection objective, which is used for extracting that retrained data set from the given training set. So the here is the function for MSSO, uh, which extract the data from the training set, and in this function Gj is a gradient of a training sample J, showing its effect on a model, and G meta I is the gradient of a meta sample I. After approximation of MSSO, we getting MCO. Yeah, from the training sample. Yeah. And after approximation of MSSO, we get MCO. Uh, MCO is uh, another version of MSSO, means we take approximation of MSSO, which is called MCO. So MSSO is close to MCO is close to MSSO. Uh, yes, sir. Yes, sir. Yes, sir. Outside the norm. Yes, sir. Yes, sir. Mm. Yes, sir. Yes. Here. Yes, sir. It's a convex function. Yes, sir. Yes, sir. Yes, sir. I mean, MCO is approximation of MSSO. I mean, yeah. So summation of absolute value is greater than. Uh, uh, MCO is less than MSSO. Sorry, MSSO greater than MCO. Oh, sorry, sorry. Yeah, MCO is greater than MSSO. Yeah, means MSSO is calcul calculating MSSO is hard. So we approximate. Yeah. So MCO is close to MSSO. Specifically, so 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 like we have to check that MCO is approximate to MSSO. So we introduce here ratio d minus 1 upon d plus 1. D is the dimensionality of the gradient vector, it's number of parameter or the features. So this fraction represent the worst case ratio between the value achieved by MCO and the optimal values of MSSO. It measures how close MCO get to the ideal solution. What is weight? Yeah. Yes, I understand. I mean, group their samples, group samples by their gradient using weighted k-means. What is weight? Yeah. I mean, yeah. I mean, weight comes from the gradient size. This is a so we have two methods for clustering. RVC, representation-based clustering, a fast method using only a last layer of neural network. In this clustering, we use a last layer of the neural network. The, here, the gradient vector of the sample J, which represent Jj is a gradient vector of sample J, which represent the influence on the model learning and is used for clustering in RVC. And AJ theta t a term derived from the last layer output adjusted by the true level, and xj theta t the, the feature representation of sample j at a last layer influenced by the model parameter theta t and a time, or and Bayes is a true level of sample, and softmax function is used for convert the row square into probabilities 0 to 1. And one hot Bayes a vector where only the position corresponding to the true level Bayes is 1 and all other are 0. So I mean, it is only last layer of neural network. What's that? So the weight of the second to last layer, the weight of the second to last layer. Yeah, this is the so another clustering method is GVC, which is gradient-based clustering. Uh, use gradient from many layers for better accuracy, and multiple layers. Use multiple layers. So delta f theta, delta f meta is the inner product between the gradient of the loss for meta sample I and the training sample J with respect to the meta with respect to the model parameter theta, and L is the total number of layers in a neural network, and a to the power L is the importance of weight of layer L, reflecting its contribution to the gradient. And A is the total importance across all layer. Uh, and under root a to the power I is the normalization factor to adjust the gradient magnitude based on the layer importance, and delta fj theta is the gradient of a loss for training sample j with respect to the parameter of layer I. So it's more accurate but slower with compared to RVC. It take means 2.5 hours versus a 3 minute for RVC. No, I mean I found a GitHub on. Yeah, it's used on multiple layers. I mean, not all the layers. We can, yeah, layers. Yeah. So, so this is how the RVC and VCC data flow. So first, the input is the process begin with the data set of noisily labeled sample X and Y, XJ and YJ, where the label may contain error and imbalance. And then after that, the gradient calculation for each sample J, the model compute gradient of the loss function at a multiple training time steps. These gradients reflect the sample's influence on the model parameter theta over time. The weighted k-mean, the GJ vector are proceed using a weighted k-mean clustering, where the weighted account for gradient magnitude meta sample are selected as a training sample closest to the clustering centroid, ensuring a diverse and representative subset. And the output, the resulting a selected metaset highlights as a red dot are used in a meta reweighting process to dynamically adjust the sample weighted, focusing the model on informative data while mitigating the impact of noisy and irrelevant samples. Yeah, yeah. Yes.
So can you have the question?
Yes. Is the project model uncertainty measurement. I mean,
Creatively, which basically create equations first maybe expand and then shrink the number of layers. L.
yes.
L can be expanded and then shrink. Or some other regular. See, what should I consider? In an L layers can be. These blocks. Damage is also noise.
Yes, sir.
It is also noise.
No, sir.
So you have a object description.
Yes, sir.
Description of the not just straight.
What means? Extracting the means extracting the good data from the training data set.
Can you just implement this?
Yes, sir. Yeah.
What is the from scratch?
I got the source code.
Articulated. Sets of anything else you want to